With that, it's a pleasure to introduce today's speaker, Charlie's. Charlie is an agriculture technology and irrigation professor at the College of Sequoia and a recipient of the 2022 Irrigation Association Excellent in Education Award. He developed a hands-on irrigation training program focused on practical field skills, water use efficiency, and workforce development for modern agriculture. And Charlie is really a hands-on person. I still remember my handshake with him. It's been years, but yeah. So with that, please take us away, Charlie.
Yeah, thanks for that introduction, Hung. Like Hung said, my name's Charlie Aby. I teach agriculture irrigation and equipment technician courses at College Sequoias here in Tulare, California. Um, I'm also doing some work with UC Small Farms here in Tulare and Fresno County, looking at irrigation systems and stuff. So today's presentation really is going to dive into kind of the nuts and bolts of irrigation and kind of getting ready for spring, right? I know, spring is just around the corner and we're probably getting ready. If we haven't already started doing some irrigation, we're probably getting ready to do some irrigation. So can everyone see my screen and everything okay? My volume and everything all right? Perfect. So here we go. And like Hung said, if you have questions, feel free to stop me. I'll try to monitor, the presentation and chat and the Zoom bar and all that. So feel free to stop me as we're going along. So let's go ahead and we'll start presenting. I need swap screens. There we go. Okay, so like I said, nuts and bolts of micro irrigation systems, kind of like a spring tune-up, right? So again, my name's Charlie Aby. I teach at College Sequoias, and here's my email and my college phone number. If you do have any questions or think of anything later on that you want to ask, feel free to reach out and follow up on that. So starting out with a basic, overall irrigation system, right? Irrigation systems today are a lot more complex than irrigation systems 30 years ago, where we might have been using siphon pipe coming out of a canal and that was about it, right? Or some basic sprinkler systems. We start out and we have our deep well pump, or we may have a pump that we pump out of a reservoir with, and then from there we go into maybe some chemical injection or some sort of injection type of system. We go into a flow meter, and then we have our primary filter system, and then from there we go through a flow meter, and then we have various control valves, and we go out to our field, and our field could be set up many different ways, whether we are doing buried or subsurface drip irrigation, or we have going into oval hose and on surface irrigation, or if we're doing drip line on trees or on vines or whatnot. So my presentation is very, very broad, but if you do have specific questions, feel free to stop me and we can answer some specifics. Um, so first and foremost, starting out with, kind of on an annual or every couple year basis, one of the best things to do, starting at the pump levels, we want to get a pump test done. So this can be done. I know down here in Tulare County, our utility company, Southern California Edison, was offering free pump tests for a while, and then that program has since gone away. But reach out to your local utility company, your electrical company, see if they potentially provide, pump testing services for, your agricultural pumps. But if you've never looked at a pump test, this is a pump test done on one of our pumps here on our College Sequoias farm. And it gives us some pretty good information on the status of our water, especially if we're pumping out of a deep well. It'll give us our pumping water, or sorry, our standing water level. It'll give us our pumping water level. It takes those water levels and then our discharge pressure, and gives us this value called total head or total pressure. And then it also looks at what our flow rate is. So pump tester will typically use different um, tools to measure your flow rate. And then if you have a flow meter, you can kind of compare what your flow rate is to what your flow meter is reading to see how accurate your flow meter is. And then what they also do is they look at the electrical energy going into your pump, and basically what they come up with is what we call an overall pumping plant efficiency. Now, a good overall pumping plant efficiency is somewhere in the neighborhood of 60 to 75%. And I know, those of you that are probably A plus students are thinking, whoa, wait a second. Last I heard 90 to 100% was good. But, if we think about a pump, we have electrical energy going through a pump or sorry, an electric motor, and then that electric motor is turning a pump. So, every time that energy changes form, we're going to lose some efficiency. So you can see here, this is a multi test pump evaluation. So they did two tests. One they did at open flow. So you can see the flow rate on this first test was 870 gallons per minute. And then what they did was they closed the valve down a little bit, reduced the flow rate, and you see that also increased the discharge pressure. The point of doing this is if we look at a pump performance curve, so this is a general pump performance curve. This pump performance curve plots out our pump performance. If we look on our y-axis, we have our head or our pressure on our y-axis, and then across the bottom here we have, or across the x-axis, we have our flow in gallons per minute or GPM. So a pump, we can see the performance on these curves, these downward sloping curves here. And what those show us is that as our flow rate increases, our pressure is going to decrease on a pump. So the point I wanted to show you of bringing this up was if we look at these green lines in here, these green lines are our pumping efficiency lines. So you can see there's one point here in the middle of the pump where we have our best efficiency point. And then as we go to the left or to the right on our pumping curve, our efficiency is going to go down. So one of the things when we closed if we go back to that last pumping test we did, if we close that valve down a little bit and increase pressure, we see that flow rate decreased and then our efficiency also decreased. So if we come back here, that's going to tell me that I am operating somewhere on this side of my best efficiency point, right? So I closed or I lowered my flow rate, my pressure increased. So that's telling me that my pumping plant isn't going to get any more efficient as my water levels drop or that pump starts to decline. So it gives me an indicator of where my pump is on that so I can start planning ahead, maybe, 5, 10 years down the road, I need to start thinking about replacing that pump unless something else drastically happens. Okay. Any questions there? All right. So moving on, one of the Cadillac devices that have been installed on a lot of systems now are called variable frequency drives. So kind of gone are the days of the on-off flip switch, and we have these variable frequency drives, and these variable frequency drives allow for pump speed controls. So a lot of times if we want to reduce the pressure or flow of a garden hose, for example, we just go over and we close the valve down a little bit. When we're dealing with high flow, high pressure systems like our irrigation systems, we can actually use or waste a lot of electrical energy by closing a valve down. So these variable frequency drives allow us to slow that pump speed down and change the efficiency point of that pump. If we come back to our pump curve here, sorry, I should have put, so we can have varying speeds of our pump, and that's going to change where we're operating on this pump curve. So that variable frequency drive just allows us to get closer into that best efficiency point. So this thing is a giant computer that is out in the field, and I know all of you are probably familiar with being out in the field. It's a dusty situation, right? So one of the maintenance tasks that ought to be done on this variable frequency drive is we need to clean the filters regularly. So there's two filters on this one. There's one in this housing here, and there's one in this housing there. They're just kind of a foam type of filter, so they've got some thumb screws. You can unscrew those and clean those out. This works off of a feedback loop, so this utilizes typically what we call a pressure transducer that is plugged into your irrigation line somewhere. So it's going to read the pressure, and when we have this thing set into auto mode, it's going to read that pressure, and based off of what the pressure is, it's either going to speed up or slow down its operation. So it's the best idea to operate this in auto mode because that's going to help us, stay in that best efficiency point based off of what our set pressure is. Okay. So here is those filters that I was talking about. There's just these thumb screws here that are holding those things in, and they're just a foam filter. So, you can, bang those out on the side of your board here and get the dust out of them best you can. If they're really dirty, you may end up, either washing those with, some mild dish detergent or even replacing those filters. So filter here and a filter there. And then here's the actual control panel of the variable frequency drive. So, turning that into auto mode, going to help our pump run at its most efficient operation. I see a lot of, I've been out on a lot of farms, and a lot of folks don't quite understand how this thing works. So they end up just flipping it into hand mode and then toggling or using the manual control to vary the speed. So, the nice thing or the advantage to having the variable frequency drive, putting it into auto mode allows it to control, the speed of the pump automatically. Okay. All right. So moving on down, so we've gone from the pump, and typically after the pump, we're going to go into some sort of filtration device. So this is a sand media filter. These are pretty common up here where we're at. I know various parts of California are all different, so I apologize if this isn't what you're used to seeing. I do have a couple others that we're going to go through as well. So, this filter system is designed to filter, and then it's also designed to flush or clean itself out. So if we look at, these modes down here, here's the filtration mode. So we have water coming in from the top right here in this inlet right here, and then that water is going to filter down through. There is a sand bed. You can kind of see that represented by that light gray area in those tanks. So water is going to get filtered through those through the sand, and then there's kind of a gravel media in the bottom of these type of tanks, and then after it gets filtered through, it'll go out through our outlet to our field. When we go into a backwash or a backflush mode, we have some special valves up here that actually open or close our inlet off and open up our backwash manifold. So then what ends up happening is water's coming in through our tank. It's getting filtered over here, and then some of that filtered water is going to come back up through our tank and lift any debris or anything like that that is caught into our sand bed up, lift it off and backflush it into either a ditch or into a reservoir or something like that, wherever we would run our backwash line to. And then the rest of that will go out to the field. And then after this tank ends up getting backflushed or cleaned out, then that valve will open back up and allow water to flow downward again. And then this tank will open up and we'll flush that one. So this is where I see a lot of problems going out in the field and whatnot, because people don't quite understand how these things work and that they require a certain amount of flow and whatnot. So some of the things we need to check here on these is our pre and post pressures, or pre and post filter pressures. So typically there's going to be a pressure gauge right up here, and we're able to check what our inlet pressure is. and we're able to check what our outlet pressure is and determine what our pressure differential is. I see a question, how often do I recommend changing gravel sand media? So I know Fresno Valves and Castings recommends changing the sand and gravel out in these every 10 years. Um, if they're operating and flushing correctly, about every 7 to 10 years is about what they recommend, because that sand it's not like your regular beach sand where it's round and all soft and whatnot. It's actually like a crushed garnet, and I have a picture. Oops. I have a picture here of what some of that stuff looks like. So this was a filter that we opened up down kind of in Reedley area. So this was close to a riverbed, so you can kind of see some of the sand, this lighter colored or this more yellow colored sand. That's like the river sand that the pump was actually bringing up into the system, and then this crushed garnet or this crushed sand right here. It's got some really sharp edges and whatnot. So we ended up on this one scraping that river sand out, because we were having some pressure differential issues um, across this filter system. So going back, yeah, check your sand levels. So opening up these ports, checking your sand levels. Typically, your sand levels should be about at that top weld before those domes start to, or before the tops start to dome over. So that's about where your sand level should be. And it's not uncommon for folks to lose about an inch of sand every year through the back flush process. Now, some of the things that I've seen happen with these, there's a valve over here on these backflush manifolds, and I've seen that valve get closed off. Well, when that valve gets closed off, then what happens is when you go to backflush, that backflush water doesn't have anywhere to go. So basically, you're not able to clean your filters. Another thing that happens is those valves will get opened all the way up. And if those valves get opened all the way up, then we end up flushing more of our sand out of there than what we should. So typically on a well set up system, we should expect to see about an inch of sand lost every year. So don't go down to Home Depot and buy, a bag of beach sand to put in there. Um, this is this uh, sand that's designed and developed to have a specific filtration requirement. So depending upon the emitters that you have out in the field, you're going to have a filter equivalency. So um, you want to make sure that you're getting the right kind of sand or the right crush sand to put back in there. So here's that filtration mode and backwash diagram a little bit larger. Then I also want to talk about backwash flow requirements. So going back to the variable frequency drive, one of the things I see out in the field a lot with people manually controlling their variable frequency drive is they turn it down, and a lot of the growers that I see using like drip tape and some of those things that require a lower pressure end up just turning the system way down. Well, turning the system way down doesn't give us the flow requirement that we need for this backflush to happen correctly. So then, as time goes on, those filters end up getting plugged because we're not correctly backflushing. So these tanks come in various sizes. So 15, 18, 24, 30, 36, 45, and 48. So you can see the flow requirements required to flush each one of those tanks effectively. So it's important to, again, another importance for using that variable frequency drive, making sure that, we're operating at the correct flow and pressure that our system was designed for. So here's that sand again. And then I want to talk about another thing we run into or see sometimes is these valves failing. So this is that valve that I was telling you about that closes off our inlet. So here's our inlet side. This is a cutaway, actually a picture I took at the World Ag Expo Fresno Valves and Castings display. So the way this valve operates is we actually put water on this side. So this is a water valve, and we have a solenoid that opens up, and that solenoid will push, that water pressure will push against this spring, and take and seal our inlet off here and open up this port, allowing water then to flow from our tank upward and go into our backflush manifold. So making sure that we have the correct pressure and flow for our system to effectively backflush, and to make sure that our backflush control plumbing system and our solenoids are working correctly on this side. So, if this is sounding a little overwhelming to you, there are companies out there, your irrigation company number one, and then there's also some independent folks that'll come in and they'll actually, take these valves off, take them apart, make sure that everything is functioning correctly. Sometimes with, a lot of wear and whatnot, these diaphragms here can get holes in them, and then, that water valve basically isn't functioning anymore. So some other, maintenance type of tasks, in springtime, it's a good idea to start the system up, initiate a backwash with low pressure. If these things have sat all winter, there's probably going to be some air in them. So starting up with a low pressure, fill those tanks up, and typically they'll hold water in them, most of the irrigation season. So, another prior to doing that, coming in and removing and inspecting the portholes, looking at our drain and our air vents, our pressure relief valves, all of our control valves, our hydraulic tubing, our ball valves, manifolds, make sure that everything's in good working order. So again, like I said, if that seems overwhelming to you, there's a lot of companies out there that will do that kind of stuff. So talking about the control side, so the control that controls the backflush, um, we have a filter here. So this filter filters the um, incoming or the inlet water. So we take some of that inlet water off, and this is what goes in to control those backflush manifolds. So it's not a bad idea at least once a month to pull this little filter off. This is just a little tube screen type of filter. So it'll unscrew here. And that just basically is filtering any water that's coming to control our three-way valves, our backflush valves. So yeah, and that kind of, well, one last part on filters is we have our backflush controller. So this is a screen of an Alextronic backflush controller. This is a pretty common one that's out there. So just wanted to go over the controls on these. So this little black button right here, this is our manual start backflush. So when we start up, and we want to put our system into a manual backflush, we can push this button here and that'll activate the backflush. And then, we have all these knobs over here. These knobs control our actual backflush settings. So there is a periodic flush. So these backflush controllers are set up to either backflush off of a pressure differential. So typically they're set up for like a 7-pound differential, meaning that the inlet pressure is 7 pounds higher than the outlet pressure. That's going to trigger a backflush to happen automatically, or we can also have a periodic flush. So you can see there are various settings. So 15 minutes, a half hour, all the way up to backflushing every 48 hours. Here on our farm, so we have 50 acres of almonds here at our school farm. We've got, our backflush set up to automatically backflush about every 8 hours, regardless of whether it has a pressure differential or not. And we're pumping out of a reservoir, and we have both surface water and well water that we're putting into that reservoir. So, it's a mixed bag of nuts as far as what we're the quality of water that we're pumping in. After that, we come down to these two knobs. Now, some controllers have a single knob. This one has two knobs that give us minutes and seconds, but basically this controls how long we backflush that filter for. So this one's set up for a minute and, yeah, about a minute and 2 seconds. Typically, like on our 48-inch tanks that we've got set up, we're backflushing those for about 90 seconds a tank. If you've got a higher sediment or higher, biological debris load, you may backflush for longer than that. And then this bottom knob down here, this is our dwell time. So this is the time in between tank flushes. So, tank number one's going to flush, And then after it gets done flushing, we're going to let the system stabilize a little bit. So that's our dwell time. And then after the system stabilizes, then we're going to go ahead and initiate that flush for the next tank. So this one's set up for 10 seconds. Typically, I like to give on the bigger tanks, give them a little bit more time than that, 40 to 60 seconds dwell time in between tank flushes. So, that way everything, has a little bit of time to stabilize and we don't have any water hammer effects or anything like that. Okay. All right, going on. So, we see a lot of sand media filters down here in the San Joaquin Valley. You may see, I know not everyone has a big one like that. So you may see like tube screen filters. So, good practice at least once a year is to take these tube screen filters off more frequently if you have a higher debris load. And basically there's this T handle here and you're gonna back that T handle out, take the cap off, and you're gonna have a big tube type of screen filter that's going to be in that thing. Again, just I put this on the last slide, or sorry, 2 slides ago, or sorry, 3 slides ago, when opening ports and doing all this system maintenance, you want to be sure that the system's depressurized, the pump is off. You don't want to be doing any of this kind of maintenance when the system's under pressure. So, you can take this cap off, pull that tube screen out, do a pressure wash on it, wash everything that's on that screen off. There are tube screens that are self-cleaning. Always a good practice to pull those things apart at least once a year, check and make sure that all the mechanisms are working correctly, and manually cleaning those filters as well. You may also run into these disc type of filters. These come in various pods and arrangements. And the way these things work is you have these discs that are all in a stack. I remind students back in the day of the DVDs or sorry, the CDs or the vinyl. Now that those are becoming obsolete, but so we have all these discs here, and these discs have these crosshatch patterns, and that's what causes the filtration as water is penetrating through there. So debris will get grabbed in or be held into these discs, and these are meant to be self-cleaning as well. So we can have a backflush manifold on these that will reverse flow water, open those discs up, but it's always a good idea at least once a year to open these things up, separate and clean those discs off, see if you've got any, growth or anything like that on those discs, get those cleaned up and put those back in there. Also, another problem with these is if we have large debris like sand or something like that that gets stuck in between those discs, then what ends up happening is we lose our filtration because all that water is going to preferentially flow in between those discs. So just a couple of things to be looking for on those disc filters. Okay. We've talked a lot about pressure and pressure gauges, and pressure gauges I think are one of those overlooked features of an irrigation system. So these are critical to determine if the system's functioning correctly or not. So, a good pressure gauge is going to be a liquid filled or a glycerin filled pressure gauge. And you want it to be within the range of the irrigation system. So most irrigation systems are going to be, somewhere between, under 60 psi. There are those exceptions out there that can be much higher in certain situations if we're running, big sprinkler systems or whatnot. But for most irrigation, drip micro irrigation systems, a pressure gauge like this is going to be sufficient. So if we look at this pressure gauge over here, maybe something that you go down to Tractor Supply or your farm supply store and you just grab a pressure gauge. This one's probably going to be set up more for like tractor hydraulics or something like that. You see that we're going all the way up to 3,000 psi. So that's not going to give you the resolution that you need to see really what's happening with your irrigation system. So, and then, this is what we run into a lot of pressure gauges that look like this, where they don't return to zero. Well, that pressure gauge is damaged, right? So, that's not going to give us the information that we need. So, those need to be replaced, and they're relatively, inexpensive for the information that they're giving us. So always a good idea to go through and check your pressure gauges in your system to make sure that they're working correctly. Okay. All right. How are we doing? Any questions so far? Or I don't, am I going too fast or doing all right? Okay, so getting into flow meters. So flow meters, these are going to give us basically, our system flow. And always a good idea to regularly write down, our total flow. So if we compare this to like in our vehicle where we have a speedometer and then our odometer, um, we're going to have a totalizer that you see here on the bottom of this flow meter. And then we have a needle that's going to give us our current flow rate. So, as this thing operates or as water's flowing through here, it's going to give us our flow rate. And then based on time, it's going to totalize the amount of flow that's gone through here. So a good practice, for either if you're on a field situation or on a farm total is writing this value down every year to see how many acre feet of water that you've used on your farm. There are, some newer, more advanced flow meters that give you digital readout, and you can hook those in with automation and monitoring and whatnot. um, some things on like these symmetric or even the micrometers is they're going to have a battery in there that's going to go out every 3 or 4 years. So just be aware that the electronics, they're going to have some batteries and stuff like that that need to be replaced. And I come across a farm every now and then that they haven't changed the battery out. They didn't know that there was a battery in there to change out, right? So these propeller type flow meters that work based off of like a boat propeller, right? Water is going to be flowing through the pipe and it's going to give us the flow rate of that system. So always good to, if you've got a system design and whatnot, to look at what your flow rate is. And if you think back to that pump curve that we were talking about at the very beginning, if you notice a drastic drop in your flow, maybe an indicator that something is happening, like your water table is dropping, or there's other issues in your system. And two, if you see your flow rate going way up, it may also indicate downstream that you have a leak somewhere that you didn't necessarily knew that you had. So I know in ag, a lot of times, we're dealing with large volumes of water. So, just be mindful and be paying attention to your flow meter. Change your batteries if you need, if you have an electronic one, and that handles flow meters. So coming down, from flow meters, we're going to get into control valves, and control valves do a whole host of functions. So there are control valves that are simple that provide us an on-off function. So allows us to turn our different um, fields on or off. They provide pressure regulation, whether it's downstream pressure regulation. So, if you have a block that, you're irrigating with drip tape, you can set your pressure regulator to 10 psi so you're not popping or blowing out your drip tape. And then you may have further on down the line, you may have a block where, you've got some trees or vines, and that system may need to run at 15, 20, 25 psi. So then you can use a control valve to vary the flow rate, or sorry, the pressure on that system. We have pressure sustaining valves. So I see this a lot on some of our smaller farms. They've got an older well that isn't producing as much flow. And if you think back to that backflush requirement for those filters to effectively backflush, what ends up happening is when it goes into backflush, it needs all the water the system can provide. So a pressure sustaining valve sustains the pressure upstream of that valve, so we have enough pressure and flow to backflush the filter for the system. So, and then these can also be hooked up with, if you have automation in your field, these can also be hooked up with a solenoid valve and be auto on and auto off. So you can control your field, control your irrigation, remotely with either your smartphone or your tablet or computer or whatnot. So some important tasks for these control valves. We want to make sure that the plumbing is intact. And what I mean by plumbing is if you look at this valve, if you look through these little wires, there is some hoses that are running through here. So these hoses, if you don't have this wire wrapped around, and even if you do, sometimes critters love to chew on these things. Coyotes, skunks, raccoons, all those curious critters love to chew on these things. And then when they chew on those, that more or less kind of renders this valve inoperable because this is a hydraulic or a water valve. Okay, so we're utilizing water to open and close this valve. So if the water isn't being maintained in where it needs to be maintained in, that valve may not close. And we've run into a couple of farms where, they have a control valve and they can't get the water to shut off, and they've had some issues with the plumbing on these things. So there's also this thing called a filter finger. So this is the filter finger is going to be installed upstream of the valve, and it's going to take the pressurized water from the system, and that's what's going to control the system. Well, if our system we've got dirty water, or if we've got, debris that builds up on that filter finger, we're not going to be able to get water into that valve to control that valve. And I think I mislabeled it here. It should be finger filter. And then we want to ensure, so if we have if this is a pressure regulating valve, we want to ensure that our pressure downstream is correct. So if you see this gray handled pilot over here, that pilot allows us to change the pressure downstream or upstream of that valve. So, it's a good idea. There's a port on the side that you can bring a pressure gauge out into, going back to those pressure gauges, and kind of like an air chuck. So there's a Schrader valve on there, so you can take like an air chuck on that pressure gauge and see what your system pressure is downstream, and you can dial that pressure in right here at this pilot. Okay. So here is that finger filter that I was talking about. You can see how fine a mesh that is. So that filter finger is down inside of that valve, and that's sensing the upstream water, taking that upstream water and allowing us to control, um, the valve with that upstream water. So if that thing's plugged up, that valve's not going to be able to be controlled. So here's another cutaway of this is a similar type of valve to that metal Nelson valve. So this is the same Nelson 1000 series valve. So you can see this rubber part in here. This is our diaphragm. So that diaphragm basically is going to close around our our port right here in our valve. So as that closes down, that's going to shut off the flow of our valve, and then as we exhaust water, so there's a port here that allows water to exhaust out to atmosphere. So as water is removed from this side of that diaphragm, that allows that valve or that diaphragm to open up. So here's that filter finger. So basically you can, envision the plumbing of this thing. Water is going to come through this tube. And then if we have this thing set to closed, it's going to we're going to have water pressure all the way around this, and that's going to close that diaphragm up around that valve so that way water can't flow through. If we're regulating pressure, we're going to have something sensing our downstream pressure down here, and it's going to work against that or work with that pilot that we talked about and regulate how much water we're allowing to flow down through this valve. So kind of an overlooked or maybe not even known about maintenance item is that finger filter. Okay. And then, like I said, critters love to chew these hoses and lines and stuff up. So if that happens, um, it's important that you get your valve plumbed correctly back. So, if you didn't have a picture of how it was plumbed, you can reach out to either your irrigation store to get a diagram like this of the correct plumbing for your valve. Taking a picture, sending it to taking it into your irrigation company, or if you go to like manufacturers, like Netafim actually has an app that has these diagrams on their app where, if you need to replumb that valve, you can do that. And, lab I have my students do is they come in and they've got all the components laying in front of them and a blank valve, and they've got to plumb it correctly. So, just be sure you get those lines. Don't just randomly hook them up. be sure you get those lines back in the correct orientation. Okay. All right. Now that we've gone, pump, we've gone through filters, we've gone through flow meters, we've gone through control valves. Let's get out in the field and talk about our main lines, our submains, our manifolds, um, and then our drip lines. So, debris is going to accumulate even with the best filtration system, we still may get debris that's going to accumulate in these systems. So, one of the things is flushing at least annually, if not more. So let's hope this video works. Here's a video of flushing. This is a manifold, so this is the pipe where all of our drip lines come off of. So you can see, it's gonna start out pretty dirty, and then it'll eventually clear up towards the end. All right, so apologize for the freezing up a little bit, but you can see, it started out real dirty and then kind of cleared up there towards the end, and you saw how long that ran. So that ran about a minute and a half or so, minute and 15 seconds, to get that water to run clear. So one of the good practice too is to take like a nylon sock or something like that and collect the debris and see what you're working with, right? If there's a lot of clay, like some sticky type of smooth stuff on that nylon sock, means you've got some clays in there. If you've got slimy algae or bacteria type of stuff on that sock, means you need to be taking care of some biologicals and stuff like that in your irrigation lines. So um, so that's a good practice on your manifolds, your main lines, submains, stuff like that, at least once a year, if not more frequently, depending upon your the loads of debris that you have in your system. Okay. Moving on down, so probably more frequently is line flushing. So you got to start out, if you haven't been flushing your irrigation lines, you got to try flushing those every 2 to 3 weeks and see where you're at. If your lines don't run clear within a minute, you may decide you may need to flush more frequently. And if it clears up pretty quickly, then you can probably go more frequently in between flushing. It's all going to depend upon your your load of debris that you have in your water. Okay. We only want to flush a couple lines at a time. We don't want to go through and open up our entire field because it's important that we have enough volume of water to correctly flush. So in this picture, you guys can see I took a emitter and I cut it apart, and you can kind of see the debris that gets, that can build up in your drip line. And then here's another video of flushing a drip line. And we installed these easy shutoffs, or these shutoff valves on the end of our irrigation lines. All right. So the next task, thinking, probably towards the end of the year is you may want to think about performing a system evaluation. So there are companies out there that'll perform system evaluations. ITRC at Cal Poly, Center for Irrigation Technology at Fresno State. They have teams of students that go out and do system evaluations. A lot of your resource conservation districts will do system evaluations. You yourself could take a class at Cal Poly ITRC. They teach a class on how to do system evaluations. But what a system evaluation is think of we go to the doctor annually and get a physical. This is basically kind of doing that physical on your irrigation system. This is going to help us determine how uniformly our irrigation system is applying water. So what we can do is we can measure flows and pressures in several parts of our system, and if we're doing it, the correct way of doing a system evaluation, we're going to take some pressures and flows in a area close to our pump, hydraulically close to our pump. So, the pipe, as water's flowing through the pipe, an area that's close to our pump, and that's going to be kind of our high pressure area of our irrigation system. And then we want to go to an area furthest from our pump. And that area furthest from our pump is going to be our lowest pressure area and probably where we're going to have the most plugging and most debris. And then we're going to look at an area, kind of an intermediate area in between our closest and furthest. Um, Basically collecting flows, collecting pressures. There's this concept called distribution uniformity. I didn't want to dive into that today because that could be a whole nother lunchtime lecture on distribution uniformity. But if you measure flows and collect flow for 5 minutes and measure in milliliters and convert that into a gallons per hour, you can compare your emitters and how well they're performing against the manufacturer specs. So, if you've got, Netafim or Toro or whatever type of emitter you have, it's going to have a rating in gallons per hour. So you can measure and determine like, hey, I've got, I'm flowing at what the system is rated for, what that emitter is rated for. A lot of systems nowadays have what we call pressure compensated emitters. So those are compensated and those work to regulate the flow where you have a consistent flow rate over a variety of pressures. So going out collecting flows and then going in and collecting pressures, and seeing what your pressure is and how your pressure compares to if you have like an irrigation design, how your pressure compares to your irrigation design. And if you see that pressure start to decline, it's going to be an indicator, hey, there's a problem somewhere upstream, is causing my pressure to decline. So then if you have any monitoring systems, so the monitoring system I've got depicted here is a watermark sensor. This is our new IC10. It has some batteries in it, right? So one of the things is if you've got monitoring systems out there that help you make irrigation decisions, and say you got a sweep grant or something like that, and that was one of the things of the sweep grant. I really encourage you guys to use those, and I'm happy to help, with figuring out how to use those. But those parts also require some maintenance as well, right? So replacing batteries, renewing subscriptions. So with this IC10, there's a subscription with those IC10s to get, that data to the cloud, and then you can download it, look at it on your computer. When you're looking at that data, make sure that data is making sense. If you've irrigated and, your watermark sensor that you see here is reading, 150 centibars, that, something's not making sense there. So we need to check and see, hey, is the sensor working correctly? Am I getting water down to the depth that I thought that I was irrigating to? So these do require some maintenance, and if we need to replace the sensors if needed. These are relatively inexpensive sensors for the information that they give, and but these also do only have a lifespan of about 5 years or so. Okay. And then last, just like that physical, right? Wouldn't be a complete physical if we didn't go down and to the lab and give a sample of blood to our doctor. So we ought to take a sample of our water and then take that water to a lab and have that analyzed. It's called an ag suitability water analysis, and it's going to give us values like our pH, our electrical conductivity, different amounts of our different cations and anions. And, there are normal values and problem values. This is going to help on the agronomic side as well as on the irrigation system and maintenance side. I won't get into all the chemistry and stuff on that, but I will direct you towards some resources. So this is a resource from UCA&R, Maintaining Micro Irrigation Systems, and it's written by some pretty phenomenal folks that have been in the been with the UC system for a while and have a whole host of knowledge in irrigation. This starts really at the drip line level and works their way backwards. So this link also will take you to kind of the free version of this, but this book was only 25 bucks off the UCA and our website and goes more into some of the chemistry and stuff that you may run into on the ag suitability water analysis. And then kind of in summary, right? Like, your irrigation system provides a major function in food production. This is how we get water to the plants that plants need that water to grow. So just like the best car, truck, or tractor, it's going to need maintenance, right? So lack of maintenance is going to cost money in system repairs, greater water use, and higher energy costs. So with that, I know I probably went a little long and I apologize for that, but if you guys have any questions, feel free to reach out to me. That is, my email and my cell phone number. And Hung, I'll hand it back over to you.
Thank you, Charlie. You did